G'day, Glenn Morris here from the Smart Energy Lab. And today I've got Ranjit back with me from ZECO Energy. Ranjit has been on this platform a few times already, telling you about some really clever stuff that ZECO Energy do. But today we want to go deeper into Marshall, right?
Yes.
Yeah.
Okay.
So maybe we'll start because not everyone's familiar with ZECO Energy. So could you give us a bit of a background on ZECO Energy and how your products like the Marshall range, which we'll be looking at, how they fit into the evolving energy landscape?
Yeah, thanks, Glenn. Thanks for having us here. We are very eager to meet your viewers and explain what's happening new in the CC pause world. Yeah, definitely. ZECO Energy is always there in the middle of all what's happening. So we started in 2014. Just a small brief background. We started with BYD batteries, and then we went over to Samsung, and then we started technical support. So that was our background till we went into installation in 2017, and since then we have been trying to find a product niche where we can play with the technology market in solar sector. And we found that we made a off-grid lighting tower which had LED lights and solar panels, and we always found that it was getting some kind of a shutdown because of the low battery state of charge and other issues. So we wanted a monitoring and control system. So we devised our own control system for that. And that was the start of Marshall technology. So we could read the state of charge of the battery remotely on a website and control the loads. So then we thought, why not we go into monitoring? Because that was one of the niche segment where there were not many options that time in the industry. So we started with a monitoring concept where we read the Modbus registers or the Sunspec registers of the inverter, and we can put it on the website. And then came the SAPIN dynamic export control requirement. That's when we really kicked into the gear. We started working with the industry and with DNSPs and finding innovative solutions. So that involved controlling the batteries, controlling the inverters, and also custom solutions, which we will go through in today's presentation.
Now, you're the tech expert, but I'm the one who asks the dumb questions. So I'm going to explain some of those terminologies there. So SOC, state of charge of batteries. It's important to know that so that you know how much is available for use. SAPN is the South Australian Power Networks, which is the utility that runs the electricity network in South Australia. And they were one of the first to realise that controlling first solar inverters and then solar and batteries really helped them manage their network.
Yes.
And you provided one of the first solutions for them as a separate device that could do that.
Yes, so there were solutions available, but they were lacking some kind of a hardware, and we found that if we can integrate the meter, because everything we talk about export, but it happens on the main switch of the switchboard, and they have a very tough telemetry requirement where they want to see the phases per phase, like voltage per phase and frequency and all that. So we incorporated a meter. So we were first to have a monitoring and control device with inbuilt meter. Yes.
Right.
And it is a 3-phase meter. It can work on like as low, it's a 5 amp output with a 2000 amp CT ratio. So it can go up to 10,000 amps. So it's a big meter. Yeah.
That should do me. Yeah, 10,000 amps sounds a nice target. So just to be clear, ZECO Energy is the company, but Marshall is the actual product or product range.
Yes, so Marshall is under ZECO umbrella.
Yeah.
And it's a brand we like to use for our technology products.
Right. So you actually came about with the Marshall product to solve a problem with these lighting towers, but now that's rolled out to solving a problem for the grid.
Yes, yeah, so it was an in-house product to start with, and then we found the market niche, and then we went for it.
So we mentioned the name Marshall as a product, but there's more than one Marshall. Can you tell us a bit about the product range?
Yes, very good question, Glenn. There is a bit of confusion among the installers what product to use. So basically all three products, there are three products, Marshall Lite, Marshall Black Box, and Marshall Ultra. All three of them can do same job, which is monitoring. You can monitor using Marshall Lite or a Marshall Ultra or a Marshall Black Box. So the difference in the hardware is Marshall Lite is a droplet, Marshall Black Box is a Marshall with inbuilt RS485 capability in a box, an outdoor rated enclosure with a single phase CT type meter. The CT type meter has a ratio of up to, so it can also do 10,000 amps, up to 10,000 amps, but single phase side is very rare to get that kind of amps. And then Marshall Ultra is similar to Marshall Black Box in a 18-pole outdoor rated enclosure but with 3-phase meter. So that meter can be configured for single phase, 2-phase, or 3-phase operation. And as I said, 10,000 amps as well. So it's a CT type meter in both of them, and Marshall light is without meter. So there are 6 main, for an off-the-shelf application of Marshall, there are 6 main functionalities we are trying to address. Monitoring, site monitoring, we can do it through Modbus register or through these Marshall meters as well. Then there is a export control. Export control can be a fixed export control to like a percentage of the rated power, or it could be a dynamic export control as well, which is more popular. And we are across all DNSPs. We can do Victoria backstop. We can do SAP-in flexible export control. We can do Energy Q, dynamic export envelope, and soon, as we speak, we will be registered in Synergy, Western Australia, and the Simply battery system as well. And then we are working with DNSPs in New South Wales, who are rolling out Essential Energy. We are working with them, who will be rolling out a flexible export program soon as well.
So basically, all of the networks are looking for solutions to control the uncontrolled, the solar and battery and residences and businesses.
That's correct.
To stabilize the grid.
Yes, that's the main reason for controlling the inverter or battery output. Like I'll come to the battery output. Right now, the only thing they're controlling is inverter and the smart loads like EV charger. And then coming to the third application of Marshall is, so we have covered monitoring and export control. Then there is this application where we can aggregate the battery power. So there could be multiple battery BESS systems on site. In old days, they used to subdivide the switchboard into parallel circuits, and each battery was doing some kind of a dedicated loads, and each of the battery had their own meter. But you don't do that with Marshall. You just put one meter, which is for the whole site. That meter gives us the load value of the site, export and import. And based on that, we then aggregate the battery power. So if it's importing, we discharge all of the batteries equally. We divide that import value equally among all the batteries. And if it's exporting, we divide that value equally and we charge the battery.
So if you had 3 battery systems from 3 different manufacturers with 3 different capacities, you can manage them all as an aggregate.
Yes. So it doesn't matter for us whether they are different manufacturers or different models, because we just go by the model and Modbus of that. So we will discover that battery as a ZECO Energy battery or a Fronius BYD battery or a NOAC battery, and then we will just aggregate it based on the power which is read by 1 meter. So you can choose any meter. It can be the meter of one of the OEMs. So we can use ZECO Energy meter or a Fronius meter or a NOAC meter or a Clenergy meter. And then we will use that meter value to read the site load value, and then we'll distribute it. So if by chance there is a problem with the site where the inverter cannot be connected to its own meter, or there is no compatible meter on the site, we can use Marshall Black Box or Ultra to read the site load value from our own meter and do the battery aggregation. So battery aggregation is pretty popular now because there would be a site where Fronius BYD is existing and someone's adding a ZECO Energy. So that's where this application really is coming into picture. And then other applications of Marshall is, so we have covered few of them like monitoring, export control, battery aggregation. And then there is a custom application as well, where we can make custom Marshall for specific purpose. Like there could be a purpose where installer wants to read the SOC or state of charge of the battery and start the generator. So we can provide that kind of extra features. We'll touch upon them in more detail as we go through. There's one more application that's escaping my mind. So we have covered
6 is a lot to remember, but while you're remembering that 6th one, I just want to do a little explainer to the audience about this term Modbus. For those who work in the electrical world will know it very familiar, but it started back in the 1970s as a way of automotive control, so vehicles to talk to the different components in a vehicle, but they then realized that it could be used as a standardized communication protocol. It's somewhat standardized, but each end user will have their own little map, their own
Modbus map.
Modbus map, and that's kind of like your challenge is how to read those values and then make sense of them. And so you need to integrate with the different suppliers. So you integrate with the different brands and talk directly over a communication cable or Modbus RTU directly, or via Ethernet, Modbus TCP IP.
That's correct.
So you've got ability to use the existing functionality of a range of products, which already have this feature built in, but you piggyback onto it to provide both monitoring and control if allowed.
That's correct. And this information is available free. So you don't need any discrete equipment like meters or sensors. It's already being there. So you just, you have to use it, and then you have to control. The whole process is like battery control is not simple. Like you are trying to control a battery for a load value. You can over discharge it, and then if there is a AC coupled solution on the side, it will then charge. So you have to balance the hysteresis well. If you over discharge, then it will go into charging mode because it will think that it's exporting. So it will go into importing. So yes, but then that's a trick. Not all of them can do fine tune the way we do. And the sixth application now I remember is the NMI metering. So the same box which is doing all these applications can also, if you replace the EM530 meter with an NMI meter, which we have got two NMI meter models, CT type. It can be used for billing. So there are sites, neighbors, sites, or we call it neighbors is a rating agency for commercial buildings, or just a normal domestic site where a Marshall box is used for billing of energy as well. So we do that as well. That's the sixth application.
I'm going to do one of my explainers again. So NMI, National Meter Identifier number, is basically the meter that you'll have that is provided by your electricity utility that they do the billing based on. But you can use your own meter as well. So you can integrate with some NMI meters and therefore take the data directly from that meter.
Yes, so that meter, NMI meter is just that it has been tested by NMI rating agency of Australia, and it is approved for billing purpose. So the data extraction from the meter is same. There is a format called NEM12 format. We can extract the data from a non-NMI meter in the same format as well. That's the format which you get when you download the smart meter data from DNSP portal. So that's the data which has to be given to the billing company.
So is that done directly between the Marshall device and the NMI meter, or is it done through an API through their cloud monitoring?
Both. So we can download the data from our backend and give it to the billing company like a CSV file, or we can give them an access to Marshall backend through an API, and they can download from directly as well.
Wow.
So our NMI metering solution is pretty popular. In fact, there are sites where we have replaced our competition meters. Our competition has got this solution where they have got rope CDs, and some of these sites have got parallel feeds. Like each phase is divided. There was a site recently where each phase was divided into 9 feeds.
Whoa.
So the competition had got 3 meters to cover that, because they are divided 3 feeds over one rope CT. And they had to use multiple meters to aggregate the main. What we did was we put CTs on each of the feed, and then we shorted the CTs, and we put another CT on the short. So just they are inexpensive. The split core CTs you can buy anywhere now. So it just has to be class 0.5 because that's what the minimum rating has to be for billing. So this class 0.5 CTs we shorted, and then we put another CT on short. So instead of using 3 separate meters for 27 feeds, we were able to do 1 meter with this arrangement. So that way it works commercially cheaper and also more accurate, because if you are trying to measure trying to measure 3 cables through one big loop, there are chances that there can be a disturbance. But if your CT is touching the cable and is properly wrapped around the feed wire, it is more accurate.
So you actually use CTs to monitor CTs?
Yes, that's correct. So yeah, that is, and sometimes the inverters are all over the place. And client wants all the inverters aggregate of all the inverters. So we put CTs on these inverters, we bring it to one place, we short them, and then we put a CT on the short. So that's another application of this metering. We are very proud of our metering solution. If any custom application where they need a specific metering solution, we can do it.
Now, you've mentioned your monitoring solution, and we've got here on the laptop a live system being monitored. Do you want to tell me a bit about your monitoring platform?
So this is very familiar to you. You look at it every day, I think. So this is
this is the Smart Energy Lab.
Yeah, this is the Smart Energy Lab. So what we started with for your site was a load control box. So we have this application of Marshall where you can control the incoming amps under the threshold of main switch. This is to avoid the main switch from tripping because the big loads have turned on. So what we do is for 2-feed circuits, we monitor the incoming amps and we control those 2-feed circuits. Could be the biggest load in the house, can be EV charger in your case. So we control that load and we keep that load on under certain criteria that in your case. I'll scroll down. So the whole site is limited to 40 amps.
You've even got my panel heater.
Yes, panel heater is there as well, which you use it as a dump load. So we have got that one as well. So what we do is, so we turn the load on and off under this threshold. So that is the load application, and there is one more circuit we control where if any energy is fed into the grid, any exported power, we turn on the load to absorb that power. In your case, we turn on a big load to keep the frequencies under because it's a mini grid. You want to control on frequency, not on export. So we do that. That was the basic application of Marshall at your site, a load controls box. But then you have so many inverters on the site. We thought, why not use your site as a test case to demonstrate that we can aggregate the monitoring of different brands. So we turned on the Modbus of 2 inverters on your site, Fronius and ZECO Energy. So now our Marshall system is absorbing those inverters as well, and it is pulling this data into this monitoring. But if the installer wants to control these 2 inverters for a fixed or dynamic export value, they can then use the third functionality of Marshall, which is export control, and they can dial up a value or they can dial up a DNSP and it will control that. So same Marshall box, which was doing load control, was doing monitoring, can be used for export control as well.
So you actually solved a bit of a problem for me. Maybe I'll explain to the audience. So the Smart Energy Lab is actually an off-grid microgrid. So there's no utility grid connected to this property. There's actually 7 homes on this microgrid. There's 9 EVSEs or EV chargers. We've added a few more since you were here. There's 2 DC fast chargers, a 50 kilowatt and a 25 kilowatt. There's a community building with 20 beds in it. There's a classroom. There's my studio, which we're in right now. And like you said, many inverters, something around the 20-25 mark. You've picked a few of the key ones to identify. But the problem we had was that the subboard that feeds my house also feeds one of the EV chargers here connected to my studio. And the subboard's only rated to 40 amps. So we couldn't really run the house charging our ZECO Energy system as well as charging the car at full rate. So you put it on a discretionary load, the EV charger.
EV charger through a contactor. And as soon as the EV charger is causing the load to exceed on that subboard, we trip it off. We trip the contactor off and EV charger stops. So that's the load control application we are using at your site.
Yeah, so that's really useful. Otherwise, I'd be running around, it would be tripping breakers and I'd have to tell people to turn stuff off so I can charge the car.
Yeah, and the whole solution can work without internet as well. You don't need internet because everything is local control as well. Internet is just for monitoring. Yeah.
Right. What else can you show us on the monitoring platform?
So we have got sites where I'll go back. So this is, I'll show you our backend first. So it's pretty clever.
So this is God view.
Yes, this is. So if we just say, this is our backend. This is used by our tech support when they get a call. So they will say, okay, what's the serial number of device, or and then they will go into it, and then we can tunnel in. We can tunnel into the site,
Yep.
and we can look at all the IP addresses on the site, and then if the installer gives us the password of their inverter, we can remotely commission it as well to talk to Marshall. So sometimes installers are in hurry, or they may not know how to turn on the Modbus. We can do it for them, and we can see all the devices.
Whoa. That is a fantastic feature, because that's like, it's 4 o'clock, you've just finished installing the system, and now you're trying to work out how to get the metering to work.
Yes,
You just go home and you ring Ranjit and say, can you do it for me?
exact scenario which happens, because while they have packed up and done their labels and all that, they call us, and while they are on the site, we'll do it for them. So that is our back end. The front end looks like this. So I'll just scroll down and go into ZECO. We are installers too. So all the installers have got their logins and their customers, fleet monitoring. Everyone gets fleet monitoring. So this is that neighbor side. I'll go here. There are two meters there, one for grid and one for PV. The grid meter is measuring current across 27 parallel feeds. You can see it's like a multi-story building, like 14 stories high.
Like an apartment building.
Yeah, apartment building or office complex, and so the switchboard is at the basement, and the inverters are on the top floor. So we have got two Marshalls there. One Marshall for this is Marshall for measuring PV, and this is Marshall for measuring grid, and then we aggregate those two on the cloud level. So then we calculate the load of the site. So that is one application of Marshall where there's metering. Then we have got there's one more application of Marshall. There's so many, I forget. So Marshall can, through the application of Marshall switchboard, we can provide the shared solar and battery power behind the NMI meter of the apartment. So you can have shared.
So virtual sort of microgrid in a way.
Yes, it is similar to that. So this is that.
So even though they're all separate NMIs, you can do a virtual net metering arrangement.
Yes. So what we do is the Marshall switchboard has got tenancy. So Marshall switchboard, we connect the solar and battery, and then there is a feed for each tenancy or apartment.
Yep.
That is one leg of. So you can consider there is a changeover switch. One leg of that changeover switch is connected to this switchboard, which is Marshall switchboard, and the other leg is connected to the NMI meter of the tenant. So if the tenant doesn't want to use green power, the changeover switch will kick them into their own meter, and they can draw from the grid. So when they draw from this green box or the green power, we bill them through a NMI meter. So basically, the whole shared solar and battery is connected to the switchboard, and then these tenants or apartments are taking this power, green power, and we mix green and grid power, because the whole site may not have enough green power to meet the requirement. So we bring in grid power as well, which we meter. So we know this percentage of green and this percentage of grid power is getting consumed by tenants, and then we bill them accordingly because the tariffs are different.
So then is ZECO Energy an electricity retailer? And
Yes, we have got an exemption. Where if we have got green power on the site,
Yes.
we can bill the tenant for that grid and green power.
Is it cheaper?
It all depends on how they want to set their green power tariffs. But yeah, that is one application of Marshall. Unfortunately, my
It's probably our internet.
yes, it's playing up. And then there are other sites where we have got there is a Marshall which is installed in a site where it remotely turns on a star delta motor. The farmer turns on the water pump remotely using the phone. They toggle a button and on it goes, and it shows them. They can dial up a time, how much time they want it to be on. So there are so many custom applications. In Western Australia, we have got Marshall in the railway station where they read the error code of the grid and the inverter. And if there is any issue, then we provide a potential free contact across a SCADA sensor. And then the SCADA of the DNSP knows either the grid or inverter is in fault. And then they take whatever they have to do, they do. But we make specific solutions as well. So that is the ninth application of Marshall, which is custom solution.
My head is swirling with all the things that Marshall can do. I think it's probably easy to say, what can't it do? Does it make coffee?
That's a challenge you are throwing. We'll take it.
I think probably one of the key things to think about when you're talking about Marshall is that it's vendor agnostic. So you don't have to be one vendor across all of your products.
That's correct. And it's you can buy a Marshall and rest assured that all the future proofing is addressed. If you add inverters, if you add load, in future we will be integrating it with smart load controls. Oh, I forgot to tell you, we are integrated with EV chargers. So EV charger on a site with OCCP protocol or a physical RS485 protocol can be controlled through Marshall dashboard as well. So we give them a link, and they can, while they are commissioning their Fronius or a Delta EV charger, they can put that link and their EV charger through OCCP will connect to our dashboard as well.
Okay, so OCPP, Open Charge Point Protocol, is a open standard for EV chargers to communicate with a third party or their control system.
Yes, so it's a protocol for controlling the EV chargers, and that protocol is housed by OCCP. I think is a free of cost organization, so you can they develop this protocol, so you can use them, or you can use, now everyone's coming with their own version of hosting a OCCP charger, so we also host an OCCP charger.
So what would the benefit to an EV owner be of having that functionality in a Marshall product?
So if the EV owner says that I want to use my EV charger but not discharge my battery or not trip my main switch, then we can control the EV charger charging rate to keep under that threshold, whatever they want. They can, for the same dashboard where their inverter is connected, and now they have installed a EV charger, they want to see both of them on the same dashboard, so we will bring it together.
Oh, right. So you got an EV charger from brand A and your inverters from brand B and your batteries from brand C, but they all end up on the same Marshall dashboard.
That's correct.
Can you do solar first EV charging? So preferencing?
Yes. We have that. We have got 4 modes of EV charging.
Yeah.
So one is the flat out mode, which is called a max charge mode. So they just dial a max charge, and as long as it's more than 1.5 kilowatt, where the EV charger will operate. The second one is a solar eco mode. Eco mode is they dial this much kilowatt I need from solar, and rest comes from the grid. And the third mode is Eco Plus mode, like they only want to use solar. As long as solar is more than certain minimum threshold of 1.4 or 1.5 kilowatt, the EV charger will work only on solar, goes on and off based on charging rate. And the fourth one is time of use, where they dial a time, EV charger will kick in automatically.
So you might have an hour of free power that you want to use to charge your car.
That's correct. You can do that through
off-peak.
Yeah, off-peak. Yeah. Nowadays it's very popular with the plans where 11 to 2 free power. So yes.
Can you set conditionals? Like, I want my car charged fully by 7 a.m., but I want a preference using renewables first, then low-cost electricity second, and anything else until I actually guarantee that it's charged up. So having like a hierarchy of conditions.
We can write a code and hardwire into that Marshall.
Yep.
Right now on the dashboard, that functionality is not there. Like we have got these 4 modes of charging and load control, but we can do that. Because the functionality so many functionalities are getting requested, so it's very difficult for us to keep the dashboard updated. So, but yes, we can hardwire the Marshall with that code for that specific customer, which we do that as well. So some of the sites, our customer says, tell us that we don't want to. There are many inverters on the site, but we want you to control only these 2 inverters. So what we say to them is, okay, give us a static IP address of these 2 inverters, dial it up on these 2 inverters, and we'll control only these 2 inverters. So we do that kind of custom solution. They can go and buy a Marshall, and then they can call us, and we can remotely do. So there's these kind of custom solutions.
Marshall's highly configurable. You just basically said that you can create custom solutions based on a customer's requirement.
That's correct.
Yeah. So in a way, I think my first statement, which is it's probably easy to say what you can't do, is there's hardly anything.
We would like to think that way, but there are always challenges coming our way. So we are always on the top of them, and we try to in a timely manner. So there are sites, there are now requirements of the customers, the big customers, solar farms and all that. They have their own gateway devices. They control the inverters through their gateway devices.
Yep.
But they want our gateway behind their gateway to talk to the DNSP. So that functionality also we are doing. Any custom solutions, if is there and you cannot find a product, you can contact Marshall, and we will more than glad to work on that.
Well, you've done that for me, indeed. So when you're talking to the big end of town, the electricity distribution businesses, they often all have their own monitoring platform, typically a SCADA-based system. Can you integrate with that?
Yes, so they tell us what kind of inputs they require. For one of the DNSPs, they want to turn on, say, ATS, a generator, automatic transfer switch on a generator, and we just provide based on a certain logic, we then turn on that generator through a potential free contact. So each of our Marshall box, the black box, has got relay contacts. So we can program the logic of that relay contact and provide a potential free signal to any SCADA sensor. So we do it in Western Australia.
I can see why in Western Australia, which, fun fact, it's the biggest geographical utility in Australia with the smallest number of customers. And so there's a lot of islanded grids in Western Australia. And so they do have diesel forming, or diesel backup.
That's correct. So they are the island. They are not connected to Eastern Board market. They are the world's biggest off-grid, you can say that, system, microgrid, off-grid.
Yep.
And they are working very well through all these arrangements they have got in place. I think on an average day, they are almost 80% green power.
Wow. So the term grid really is not quite correct, because then it's not an interconnected grid. It's a bunch of islanded grids which have a single management platform, their SCADA, that can see across all of those systems, and you can plug in Marshall into that and provide more monitoring and control.
That's correct. So any site-specific requirement of a DNSP or a customer, we will be glad to incorporate in our Marshall logic.
Now, we've talked about this in previous interviews. The standard for controlling systems on the grid, CSIP AUS. I always forget the acronym. What's CSIP stand for?
Common Smart Inverter Profile.
That's it. That's it. Common Smart Inverter Profile. And the AUS is because it's based on an international standard, isn't it?
So yeah, it's based on 2050 IEEE 0.5, but then Australia adapted it, and there is an Australian version of it. That's why I call it CCPOS.
Right. So that's being used by many of the utilities in Australia now as a way of providing dynamic control.
That's correct. Both for import and export, they are using it, and it's the CSIP version SEP2 is getting used. So there is a variation of that coming as well under testing, and Marshall has been chosen as a gateway device by the DNSP to test out this enhanced version of CCPOS. It's a pretty exciting what they are doing there.
So what's the enhancement?
So enhancement is they want to unlock the demand flexibility by using a very targeted control of the active power of battery storage. So battery storage is what you call so all the alluvial gold in the solar world has been dug.
Yep.
We have we can control PV, we can control EV charger, but now we have to dig a little bit deep and for grid stability, and we have to control batteries. So that's the logic. So if the demand on the grid is very low, if the battery absorbs the grid power and charges from that, so the demand goes up in the grid, which will make the grid stable. If the demand on the grid is high, then battery can be discharged. Otherwise, the only option for DNSP is to shut down the power or the load, which they don't want to do. So they want to use this battery control to provide more stability. And if they and another option they have got is that if they know that demand on that day in future is going to be high, they will then charge the battery from the grid, and they will keep it charged. They will not allow it to discharge. And when the demand is high, then they will discharge the battery. So that way, another aspect of grid stability can be used. And then they have got very clever logic where they can turn on locally. Marshall Gateway can turn on the generator if the import power is more than they allow. Instead of cutting down the loads, they will turn the generator, and together.
This will be CNI customers, I presume, with a backup generator.
Yeah, that's correct.
Yeah.
Customers, and they have this load issue as well. So this is the enhanced. So CSIP has got a lot of placeholders which are not getting used. So DNSP are now looking to those placeholders and trying to repurpose them to. So whole battery, the battery would be aggregate of all the batteries, not one battery, all the batteries. So they wanted a gateway which is compatible to a lot of batteries and which can control them. So that they found us useful in that aspect. So we will be controlling the aggregate of battery on the site.
So just a little explainer about the benefit to the network and also to the end users is that, so we've got a program in Australia at the moment, now sort of mid-October or late October at the moment, and there's been something like 75,000 battery systems installed under the Cheaper Home Batteries program. In terms of gigawatt hours, that's basically another coal-fired power station has been installed since the 1st of July, which is pretty amazing. And having all of that under some form of control means that you've now got a really valuable asset the utility has. And previously CSIP was focused on solar and EV charging. Adding the enhancement, adding the energy storage gives it another whole breadth.
Yes, that would complete the whole picture. And in future, if there is a V2G kind of appliance, and it has got a battery behind it, like a EV car, they would control that as well through the same enhanced version.
I think V2G is kind of the sleeping giant at the moment because there's still the impediment of the vehicle manufacturer to allow it. But we've solved all the other problems, which is we have a standard for it. So for ASNZ is 4777 Part 2 and Part 1 for installation. We've got already some of the DNSPs going, yes, that's fine. They've lined up. We just need the vehicle manufacturers to go, yes, you can use your vehicle as a battery.
Yes, that is the missing piece of jigsaw. If OEMs of automotive OEMs will allow their batteries to be discharged or charged outside their normal operation, then grid will have a lot of stability with these big battery banks sitting in each car.
Yeah, I mean, I like to joke that buying an EV is basically buying a big battery at a very low cost with a car thrown in for free. And it will probably be the biggest battery you ever own compared to what you might have tacked permanently to the side of your house.
Yeah, 100 kilowatt hour in a Tesla.
Yeah. That's a lot of battery. Yeah. So now you just gave an example of a commercial site, and you also focused on an example for the Smart Energy Lab. Have you got an example, say, just a typical residential site?
Yes, sure. It's got a Q-cell inverter. It's a BESS system, so it's got solar, it's got charging. Let me pick out a system under the control of DNSP. So these are all legacy systems; they are not getting control.
So under the control of a DNSP would be like a backstop system in Victoria?
Backstop system in Victoria. Let's see.
While you're looking, I might sort of add that there's some manufacturers of BESSes have their own solutions, but it means they have to apply to each of the DNSPs to get approved. So they'd have to go to South Australia to get their solution approved, or Victoria or Queensland. But when using the Marshall device itself is approved as the means to implement CSIP AUS.
That's correct.
So it makes it much easier for manufacturers to enter their product and get approvals from the DNSPs.
Yeah, so right now, EnergyQ DNSP are the only ones who recognize the gateway device, and whatever is compatible to the device is allowed to be added to their network. Other DNSPs, they use the association of the gateway device with the inverter as listed on CEC, and that combination, they use it as a combination. But Energy Q is the only one which you just looks at the gateway device.
So when you say a gateway device, the Marshall.
Marshall, yeah.
Yeah. You know, I should just grab one because people are probably wondering, what is this Marshall? It's can be as small as this.
And this small device, Glenn, on this side is controlling a Toro and 3 BYD setups. And each of the BYD setup is fully loaded with 2 banks. I followed on how much amps are, but yes, so there are 4, and this being controlled by this. So it's aggregating the battery power of Fronius BYD with one of them being Toro.
So from an installer's perspective, they're effectively plugging in the data port on this device into the customer's home network. They can connect by Wi-Fi as well?
Yes, this can connect through Wi-Fi or LAN into the network, and it will discover the other devices on the network, and it will control them.
So they just connect power to it, either wireless or LAN connection, scan the QR code and off they go?
No, this QR code will take them to the login page. They can just register. So there is no commissioning required for this. When they are registering it, they just enter this serial number, which is here. And as soon as they enter the serial number, it will come up with all the compatible devices on the side. They can choose the device they want to control.
So it automatically scans the network for devices that are connected.
That's correct.
So things like EV chargers, inverters, battery systems.
Yes. So whatever is compatible,
meters.
It will look at the models of that and model and say, Fronius Gen 24 serial number this. Do you want to use this?
Right.
So once you say yes, you go to the next page, and then you say, okay, after entering the site details, you say, it will ask, where are the grid values coming from? You'll say, oh, grid values are coming from this serial number of this inverter, which is connected to the OEM meter. Or you can say grid values coming from Marshall meter, which will show up as well. And it will ask, where are the PV values coming from? You'll say, oh, these are the serial numbers of the inverter. I want to aggregate the PV values. Where is the AC coupled battery value coming from? You can choose the serial number, and everything is then collected. And then you define what you want to do. Fixed export control, dynamic export control, load control, or just the monitoring. If you want to just do monitoring, just say 100% of fixed export control, which is not controlling anything. And so
it's very flexible. I mean, if the installer makes a mistake and hasn't specified the right energy source for whole of the installation, it's just a software change.
So they just go back to the site and they edit configuration, and then they go in.
Right. So they can look at it and go, that doesn't seem right. Why are we exporting when we're importing? Oh, I've chosen the wrong device.
That's simple.
And they don't have to be local. They can do that remote.
Yes, everything is remote. You don't have. Once this is installed on the site and has got internet, you can even scan the devices and configure them.
That's amazing. Yeah. So what kind of data visibility or analytics do the end users get?
End users will get a dashboard with everything except for.
So we're looking at an animated graphic of the house with energy flow and state of charge and power. Do we also get any historical analysis?
Yes. So it will show analytics. They can go into analytics. They can do daily. They can do weekly. They can do monthly. They can choose all the attributes they want to look at. They can tick them on and off. Like say example, these are these.
Right. So we can see here the production and the generation.
Generation, and then this one is site aggregates.
So site aggregates is where you've got multiple devices. You might have a solar inverter from brand A and a battery from brand B and an EV charger from brand C.
Yes. So PV, load, grid, they can tick and untick whatever they want to see. In battery performance, it will have each of the battery. There are 4 batteries here, 3 batteries, 1, 2, 3, and aggregate as well. So they can look at the total battery. They can look at individual battery as well.
Right. Wow.
Yeah.
Oh.
And then they can look at the aggregate as well. And then the meter is important. They can look at what the meter is reading as well.
Now we're looking at this on a laptop. What about on a device like a mobile phone?
Yeah, same. So there is an app for this as well, Data Marshall app. So it has got, it adapts to the phone, and it has got some extra features as well for better monitoring and control.
Yeah, cool. So, sort of going forward, how do you see the gateway and site control technologies evolving over the next few years? You know, such as VPPs, virtual power plants, and demand response modes.
So we still believe that we have to cover the market, whatever is getting introduced, the new batteries, new inverters, and then we believe that in future, once the gateway is on the site, we can then give the API access to whoever is interested in controlling this asset.
Like a VPP supplier can have it. They don't actually directly talk to this device. They talk to your cloud through an API.
That's correct.
Right. And then they can offer the VPP benefit, you could say, to the customer.
Yes. And because it could be any, currently there is no specification or guideline that what is API access for what parameter. So that's where we can attend. Like they want to do battery power, they want to do control for that. They want to change the rating of SOC threshold or anything. So we can give whatever API access of any parameter they want. We can give them and control as well. So that is where we think that in future it will be going to that kind of direction, VPP control of your devices. And otherwise, DNSPs are also coming with intelligent controls, so we are ready for that as well. So.
Oh, what's this intelligent control? Is it AI?
No. It's enhanced. Sorry, I worry.
Enhanced.
Intelligent is you should not use that word
because everyone likes to sprinkle a bit of AI magic dust on
magic
everything.
Dust on everything.
So, looking into your crystal ball, what can you see? Future features and functionality that you might be looking at.
So we have to work with industry, and if industry wants something, we will make that. But on our own, we are progressing with covering as many hardware as possible, working with DNSPs, working with stakeholders like OEMs or retailers, and then we are designing our own because the custom solution or connecting a Marshall or choosing a Marshall itself is very diverse spectrum, a big spectrum. We are designing our own AI platform as well, where you can ask a specific question and we will try to give an intelligent answer to that for a Marshall specific question. And then if there is a custom solution you want, you can ask that and we can give you at least some basic framework of the custom solution, and that will allow you to think in that direction, and then you can come to us and we can design it.
Right. So you're training your own AI models.
Yes. Yeah. We are doing it for Marshall as well. So
right
now we have done it for few OEMs.
Yes.
And we are finding that we are even better than in some aspect better than Google Gemini for answering some, because we heavily use our background from single line diagrams, installation manuals to feed into our model. So yes, we are confident that Marshall AI will be the good interface between us and the prospective customer.
Cool. Well, kind of in closing, for installers and energy managers who want to learn more, what's the best way to get started with Marshall?
They can always approach us. We have got on our website a lot of installers say how we have got a tab called how can we help you, and they ask us specific questions. Like recently there was an installer who wanted to install a ZECO Energy on a Fronius site, so he asked us a question and we got the email and we explained, yeah, you can do it through Marshall Light. Another installer wanted to install a ZECO Energy on a two-phase side. We said, yeah, you can do it through our meter and use our meter as a gate meter for telemetry and total site value, and install one ZECO Energy per phase. So all these questions you can ask us. We have got a website where you can ask us, or you can call us directly. We are more than happy. So you share your SLDs, your any site-specific requirements, and we will design a specific solution.
What's the website URL?
datamarshall.au.
datamarshall.au.
Yes.
I'll put a link in the description, but it's pretty easy to remember. I love a nice, simple URL.
Yes, not many words there.
Yeah. Well, Ranjit, thank you so much for coming to the studio and explaining all the wonderful things that Marshall can do. And I'm sort of excited to be a bit of a guinea pig for some of your new developments.
Sure, we will always work closely with you. We are excited when we see there are so many toys to play around, and we want to be here. We want to install, and we want to be part of your whole setup.
You're welcome to play with my toys. So thanks, Ranjit.
Thank you very much.
Cool. Great.